talking about vectors, and actually vectors are pretty easy. What we do with them is pretty easy if you just follow along and keep up with them. Alright, so let's just define a vector. A vector is just a line segment with an assigned direction. So I've got a line segment, I've got an arrow indicating what direction this thing's going. So we have an initial point, and then we've got a terminal point. And like I said, the arrow just indicates the direction this thing's going. The magnitude is the length of the vector. And we actually denote a vector, so let's call this vector u. We would denote it with that line segment with the arrow above it, or it could just be in bold. I think your book uses that bold. Obviously I'm not going to use bold, I'm going to use this notation so you can see what I'm talking about. Alright, so let's just look at some vectors geometrically. So I gave you some vector, let's call this vector u again, and let's just make it look like that. Alright, so here's my vector u. Alright, what would 2u look like? Well, 2u would just be twice that. Alright, what would 1/2 look like? Well, that would just literally be half. Alright, and then if I put a negative, let's do negative. Alright, so if I put a negative on there, that's going to be the same length, except it's going to be going in the opposite direction. So when you see a negative, that's going in the opposite direction. Alright, so let's add some vectors and subtract, just geometrically for now. Alright, so if I'm looking at two vectors, I want to look at vector u, and I want to look at vector v. Alright, if I add these two vectors, what's going to happen? Well, if I add u, and then I take v, and the terminal part of u, is where I start my vector v. There's my u, there's my v. The new vector formed by these two vectors is going to be the sum. So that's going to be u plus vector v. This vector right here would be those two vectors if I added them. If I subtracted, let's do vector u minus vector v. Alright, so what's going to be important here is that you remember that adding is the same, subtracting is the same thing as adding a negative. And I've already talked about a negative vector. So a negative vector is just going to be going in the opposite direction of whatever vector v is. So I'm looking at u, and then when I come up here to draw vector v, it's going to be negative, so it's going to be I'm going to be going in the opposite direction. So instead of going down like that, I'm going to be going up like that. So there's negative v. And this new vector is right here. So this forms my new vector. So this is u minus v. Alright, and that's not hard if you just remember that u, instead of subtracting and thinking, what does that mean? Just add the opposite. And remember that you go for negative vector, you go in the opposite direction. So let's go on from the geometric representation and let's talk about component form of a vector. So if I've got a vector and it's in the plane with an initial point P, that's where I start, xy, and my terminal point Q, that's where I stop, then to write it in component form, I'm just subtracting my x values and then just subtracting my y values, and that's going to give me component form of this vector. So actually it's probably going to make more sense if I draw it out. So let's look at this. Alright, so we've got -2, 5. That is my initial point. And then I've got 3, 7, that is my terminal point. So I've got this vector that looks like that, and we named it V. Alright, if I'm writing this in component form, I'm just taking the x's and subtracting the difference in the x's, and then the difference in the y's. So this component form is actually going to be 3 minus a negative 2, which is 5, 7 minus 5, which is 2. So my component form of this vector is written like that. Alright, well, let's look at this. So here's my vector, and let's just think about what's going on here. If I dropped a right triangle down here, then we know that this distance right here, that's my x distance, that's 5, and then my y distance right here is 2. So this is 5, this is 2, right? Alright, so this should maybe help clear things up, especially about what we're about to do. So here's my vector. This is written in component form. Now if I want to find the magnitude of this vector, remember the magnitude is the distance. And since I've already dropped this triangle, you might can guess how we're going to get the distance of this vector. It's really not anything differently than we've been doing at the very beginning of this course, even when we worked with polar coordinates and we found the modulus. It's the same thing. Alright, I'm still using the Pythagorean Theorem. I'm looking for this distance right here. And if I let this be A1 and A2, and that's just by convention, I'm going to label that as A1, A2. So my distance, my magnitude, and the notation we use are double bars around my vector. Sometimes you'll just see one bar. In fact, I'll probably just write one bar just because it's a pain to keep this notation going. But the magnitude or the distance of this is going to be the square root of the first component squared plus the second component squared, which you can clearly see by the Pythagorean Theorem. So let's find the distance of this. Well, the distance of this is going to be the square root of a squared plus a2 squared, which is going to be the square root of 25 plus 4, which is the square root of 29. Alright, so like I said, nothing new. This is component form, and not hard. Alright, another form that's you're gonna come across in your problems are gonna be if the vector is expressed in terms of I and j. Alright, so this is real easy to swap from either form. So if I got this vector, notice it's in component form, I can write it in terms of I and j just by putting my first component with I and my second component with j. Alright, so the easiest thing to do with all these problems is I always just go back to component form because that's the form I'm most familiar with. So if I've got this component in I and j form, the first thing I'm going to do is write it in component form. So remember, this is the first component, so that's just going to be 2. This is the second component, so that's going to be 1. So now I've got u written in component form. V written in component form is just going to be 3 and negative 2. Alright, and now I'm able to do with whatever they ask. Alright, so the first thing they ask for is the magnitude of vector u. The magnitude, remember, is the square root of a squared, the first component, plus the second component squared. So that's just going to be the square root of 4 plus 1, which is the square root of 5. Alright, and you can do v the same way. 2u. Alright, so we haven't really talked about this, but when you've got a constant and you're multiplying, a scalar multiplication, you just multiply that number by both of your components in that. So 2u would equal 2 times 2 and 2 times 1, or 4, 2. This is just scalar multiplication. Same thing with this. I'm going to multiply both of my components in v by 1/2. If I add u plus v. Remember we did this geometrically. So now I've got 2, 1 plus 3, negative 2. I add the corresponding component. So this is going to be 2 plus 3, 1 plus negative 2. Now you don't have to write all these steps out, but I'm just writing them out so you can see them. So my final component is going to be that. Alright, and then the magnitude, subtract. Find the magnitude of u, find the magnitude of v. We found the magnitude of u, which was the square root of 5. You would find the magnitude of v, and then just write the difference. Okay? Number 48 in your book. Alright, so 48 asks for the magnitude and the direction in degrees of a vector. So I've got this vector, and I'm given its components are negative square root 2 over 2, negative square root 2 over 2. Alright, so the first thing I want to do is find the magnitude of that. We know how to find that. The magnitude is just going to be the square root of my first component plus my second component squared. Alright, when I square this, I get negative 2, the square root of negative, the square root of 2 squared, which is 2 over 4. So that's just going to be 1/2. Same thing here. So 1/2 is the square root of 1, which is just 1. Alright, so I know the length of this is 1. Now I want to find the direction. Well, let's think about how we would find the direction. So I've got this component, and let's just draw it out here. So I've got, so here's 1. Let's just say that was 1. So I'm doing negative about 0.7 down to about 0.7. Alright, so I'm looking at this right here, and I want to know the direction. So what am I looking at here? Well, I'm looking for theta. Alright, and I'm given this, and I'm given this. So I've got my opposite and I've got my adjacent, which means I know the tangent of theta is going to equal the opposite, which is my second component, over my first component. Alright, so I'm looking for the tangent of theta equals 1. What quadrant is this in? Well, this is in quadrant 3. So I'm finding my reference angle. I know is 45 degrees, and I want the angle out of quadrant 3, so it's just going to be 180 plus 45 degrees. So theta in this case is going to be 225 degrees.